Box and whisker charts provide a simple way to visualize the distribution of values in a list of numbers. For example, here is some sample data and a box and whisker chart of that data. The data in this example is a list of temperature measurements. The whiskers in the chart extend from the lowest temperature to the highest temperature, and the height of the box shows the range that includes the central half of the temperatures. The line in the middle of the box is called the median of the data. The median is the temperature in the middle of the data, so half of the temperatures are above the median and half of the temperatures are below the median. For comparison, here's a number line plot of the same data which shows the temperatures as dots on a number line. The box and whisker chart essentially divides the data into four groups with 1/4 of the temperatures in each group. The lowest 1/4 of the temperatures fall along the whisker below the box, the highest 1/4 of the temperatures fall along the whisker above the box, and the other 2/4 fall above and below the median within the box. The dividing lines between these groups are called quartiles. Quartiles can be computed using the quartiles function. The lower edge of the box is the first quartile, the median is the second quartile, and the upper edge of the box is the third quartile. Quartiles are also sometimes described using percentages. 1/4 is the same as 25%, for example, so the first quartile is also called the 25th percentile, or sometimes the 25% quantile. The second quartile is the median, and the third quartile is the 75th percentile. Positioning the mouse pointer over the box or along the whiskers brings up a table with 5 numbers. In statistics, this set of 5 numbers is called a 5-number summary of the data. The 5 numbers are the minimum, the first quartile, identified in this display as 25%, the median, the third quartile, identified in this display as 75%, and the maximum. The 5-number summary gives basic information about the distribution of numbers in the data, and in particular gives what's called location and spread information for the data. Location refers to the position of the data along a number line, and spread refers to how spread out the values are on the number line. Another number that frequently comes up in statistics is the interquartile range, which is a particular measure of spread. The interquartile range is the difference between the third quartile and the first quartile, which can be computed from the quartiles or by using the interquartile range function. In the box and whisker chart, the interquartile range is the height of the box. Box and whisker charts are particularly useful for comparing several data sets, mostly because they provide a compact way of summarizing a lot of data in a small chart. For example, here are 4 other data sets. Each of these data sets is a list of temperature measurements at a different location. And here is a box and whisker chart for all of that data. The chart labels option is included here to add labels below the box and whisker for each data set. A chart like this provides a nice way to compare datasets. For example, comparing dataset 1 with dataset 5, this chart shows that these two datasets differ primarily in location rather than spread. In the chart, the range is represented by the whiskers, and by the sizes of the boxes are roughly the same for these two datasets, but the median temperature is significantly higher for dataset 1. These features can also be seen in a number line plot. The spread of the dots in the number line plot is roughly the same between these two datasets, but the dots for dataset 1 are at significantly higher temperatures. In contrast, datasets 1 and 3 differ primarily in spread rather than in location, and that feature is also nicely displayed by the box and whisker chart. These two datasets have roughly the same median temperature, but the whiskers and the box for dataset 1 are significantly bigger, which in practical terms means that dataset 1 represents significantly larger variability in temperature.